Welcome to Debug Log, software engineering war stories, architecture decisions, and lessons learned the hard way. Let's dig in.
All right, so I just read this report and it hit me with a statistic that honestly, I'm still trying to process. Companies like Ramp, the finance automation platform, are reporting that 30% of their merged pull requests, the actual code changes making it into production, are now authored entirely by an in-house AI agent. 30%?
Yeah, that number is wild, isn't it? And it's not even the most radical part of the story. The report also highlights a security company, StrongDM, that has completely eliminated human code review for their AI-generated code. Their mantra is literally, code must not be written by humans, code must not be reviewed by humans.
Wait, no human review? For a security company? That just feels fundamentally wrong. I mean, we've all seen enough AI hallucinations to know you can't just blindly trust these things with critical systems, right?
That's the schism the report talks about. On one side, you have these pragmatists like Stripe, who are pushing AI to massively parallelize coding tasks, but they mandate 100% human review. They've shifted engineers from writers to editors. Then you have these radicals like StrongDM, who are basically saying, we don't care what the code looks like, only what it does. And they've built an entirely new system to validate that behavior at massive scale. It's a huge philosophical difference in how we approach software development.
That's fascinating. It really makes you wonder about the future of our jobs. Are we all just going to be editing robots now, or are we going to be designing entire digital universes for them to play in? We need to unpack this.
Absolutely. The report paints a pretty clear picture of how we got here and where it's going.
So let's start with the why. Why are these elite engineering organizations, the Stripes and Shopifys of the world, building their own AI coding agents from scratch, instead of just buying one of the many commercial tools out there? I mean, off-the-shelf solutions are getting really good.
That's the build versus buy question that's been debated since the dawn of enterprise software, right? And for these companies, the report suggests it boils down to something more practical than just a not invented here mentality. They've got these incredibly complex, mature code bases, proprietary frameworks, and a deep ecosystem of internal tools. An off-the-shelf AI just can't grok that kind of specific, deep context.
So it's about the deep integration? Like a generic AI might be able to write a basic function, but it wouldn't understand Stripe's specific internal API for, say, idempotency keys or how their deployment pipeline works.
Exactly. The report uses Stripe's minions as a prime example. These agents were built specifically to navigate Stripe's intricate internal ecosystem. They're designed as one-shot unattended systems, meaning they get a task and they're expected to deliver a completed pull request without human intervention until the final review. A commercial tool just can't achieve that level of deep contextual understanding of internal documentation, issue trackers, and custom build systems. It's like trying to teach a new developer about your entire company's specific way of doing things in an hour. It just won't happen.
And the report mentions Stripe even forked Goose, an open-source agent from Block, to get started. That's a classic move, right? Build on existing foundations, but customize for your exact needs.
Precisely. It's not about reinventing the wheel, but about shaping that wheel to fit your specific vehicle. The goal is to give the AI agent the same level of access and context as a human engineer. That's the game changer. Without that, it's just a fancy autocomplete. With it, it becomes what the report calls a genuine, albeit junior, member of the engineering team.
That makes a lot of sense. So once they decide to build, is there a common playbook they're following? Or is everyone just reinventing the wheel again, but with AI?
Interestingly, no. The report highlights a convergent architecture that has independently emerged across companies like Stripe, Ramp, and Coinbase. It suggests a clear set of best practices for building these autonomous coding systems.
Okay, give me the blueprint. How do these things actually work?
It typically starts with invocation. These agents are often summoned from familiar developer workflows. Think Slack commands, comments on a GitHub issue, or even an integration with a task manager like Linear. The idea is to make it super low friction, a natural extension of an engineer's existing habits. No jumping through hoops to get the AI to do something.
So, like @AI fix this bug in module X in Slack, and off it goes?
Pretty much. But here's where it gets really clever and, frankly, critical. Sandboxing. This is the core of their autonomy. The agent's work isn't executed directly on your production environment or even a shared dev environment. It's spun up in a secure, isolated sandbox. Think of it like a disposable, self-contained mini-computer that the AI gets to play in.
Ah, like a virtual machine specifically for the AI, so if it makes a mess, it doesn't break anything important.
Exactly. This sandbox is the agent's body. It allows it to not just write code, but to compile it, run tests, install dependencies, all without any risk to production systems. It contains the blast radius of any potential errors, allowing the agent to experiment and iterate without human supervision for every single action.
That's a huge leap forward for autonomy. So it writes code, tests it in the sandbox, what then?
Then it enters the CI/CD loop. The agent interacts with the company's continuous integration and continuous deployment pipeline just like a human engineer would. It pushes code to a branch, triggers automated tests, and crucially receives feedback from those test results. At Stripe, the report notes that if tests fail, the agent gets one opportunity to fix the issues before the task is handed back to a human. That's an intentional limitation to prevent wasteful, endless retries.
Smart. Give it a shot, but don't let it burn through compute cycles endlessly trying to debug something it's clearly stuck on. And finally, what's the output?
The ultimate output is a PR-ready output. The agent delivers a pull request, formatted according to the company's standards, ready for human review. It seamlessly integrates into the existing code review process. This is why these systems are so powerful. They handle the mechanical, time-consuming toil, allowing human engineers to focus on higher-level judgment and design.
That's a really well-thought-out system. It feels like they've learned a lot from how humans develop and tried to replicate that flow, but with AI.
Absolutely. It's a testament to how these companies are adapting existing best practices to this new AI paradigm.
Okay, so we've got this sophisticated architecture. Now let's dive into the philosophical schism you mentioned. You've got the pragmatists, like Stripe, and then the radicals, like StrongDM. Let's start with the pragmatists. How are they deploying these agents?
The pragmatic approach, championed by companies like Stripe and Ramp, is all about augmenting human engineers. It's not about replacement, but about scaling human output. They leverage AI to parallelize the time-consuming coding tasks, but they keep human oversight for quality control and complex decision-making.
This sounds like the engineer as editor model you mentioned earlier.
Exactly. Stripe's minions are the poster child for this. But critically, every single one of those is 100% agent-written and 100% human-reviewed.
That's insane. That's like 260 PRs per workday? How many human engineers would that take?
It fundamentally changes the role of the engineer. Instead of writing the code, they're orchestrating the AI and then reviewing its work. It's like having a team of highly efficient, albeit junior, assistants at your beck and call.
And Ramp's Inspect agent achieved a similar level of impact, right? The report said it accounted for 30% of all merged PRs in their main repositories within months.
That's right. And what's even more impressive, according to the report, is that this adoption was entirely organic. Engineers chose to use Inspect because it genuinely made their lives easier and faster. A key to its success, much like Stripe's minions, is its deep integration with a wide array of existing development tools.
So Inspect doesn't just write code, it can also query telemetry to verify correctness or check feature flag status, just like a human would? That's really powerful.
It is. This human-in-the-loop approach is seen as a powerful and scalable trade-off. It acknowledges that current AI still has limitations with novel or highly complex problems, but it absolutely crushes the vast amount of routine coding that takes up so much of a developer's time. It's about letting AI handle the grunt work, freeing up humans for higher-order thinking.
Okay, so that's the pragmatic side. Now, tell me more about these radicals at StrongDM, because no human review for a security company sounds like a recipe for disaster to my ears.
It definitely raises eyebrows, and it's a stark contrast. StrongDM's software factory operates under that provocative mantra we started with. Code must not be written by humans. Code must not be reviewed by humans. They treat AI-generated code as an opaque artifact, almost like the weights in a machine learning model. You don't inspect the weights, you test the model's output.
So they're not trying to understand the code itself, they're just focusing entirely on its behavior? That's a massive shift in philosophy. How do they ensure quality and security without anyone looking at the code?
That's where their digital twin universe, or DTU, comes in. The report describes it as a sophisticated testing environment. Instead of running tests against live services, which would be slow and expensive, their AI agents are tested at a massive scale within this DTU, using massive-scale behavioral validation.
So it's like a fully simulated internet that mirrors all their dependencies, but they control it completely.
Exactly.
It sounds like the AI started getting better at self-correction and multi-step reasoning. So what's the human engineer's role in this lights-out factory model then?
The report doesn't explicitly detail the human engineer's role in this model beyond the elimination of human code review. It focuses on the system's ability to validate behavior at scale.
It's a huge leap of faith, especially for a security company. But if they can truly validate behavior at that scale, it forces a level of rigor in specification that could ultimately lead to more robust software. Still, I can't help but wonder about novel bugs or unforeseen edge cases.
That's exactly the open question the report raises. How will such a system handle truly novel issues that haven't been accounted for in the digital twin universe? It's a high-stakes gamble, but StrongDM clearly believes the rewards of massive, unconstrained automation outweigh the risks.
This is all mind-blowing stuff. It feels like we're just at the beginning of this shift. Are these sophisticated systems exclusive to the tech giants, or is this becoming more accessible?
That's the good news. The report indicates that a new ecosystem of open-source frameworks is emerging to democratize this. They're designed to lower the barrier to entry for building these in-house AI coding agents, so you don't necessarily need to be a Stripe to start.
Okay, tell me about these frameworks. What are the key players?
Shopify, for instance, has open-sourced Roast, an open-source framework.
That sounds incredibly useful. What else is out there?
More recently, LangChain, which many developers are already familiar with, has released OpenSui. This framework explicitly aims to replicate the architectural patterns we just discussed, the ones seen at Stripe, Ramp, and Coinbase.
So it's basically offering the best practices of the industry giants as a plug-and-play solution?
Exactly. It provides the building blocks for more companies to create their own AI coding agents, democratizing these architectural patterns.
Wow, so it's not just about building an agent, it's about orchestrating a team of AI agents, each with a specific role. That's incredibly sophisticated. This really does sound like it's making these advanced capabilities much more accessible.
It signals a maturation of the entire space. We're moving from bespoke, one-off implementations by the biggest players to a more standardized and accessible approach that a wider range of companies can adopt.
So with all these AI agents writing, testing, and even reviewing code, how do we even measure engineering productivity anymore? Lines of code definitely don't cut it when a robot is doing the writing.
That's a crucial point, and the report dives into this, suggesting that traditional metrics are becoming less relevant. A new key performance indicator, or KPI, is rapidly gaining traction: the percentage of PRs merged from background agents.
That makes total sense. It's a direct measure of how much actual shippable code is being contributed by AI. And Ramp, as we mentioned, is a leader here.
Absolutely. Ramp's Inspect agent accounts for that massive 30% of merged pull requests in their primary repositories. The report emphasizes this isn't just a vanity metric. It's a quantifiable measure of the AI's impact on the development lifecycle. And remember, that 30% was achieved organically. Engineers chose to use it.
This level of automation fundamentally changes the calculus of engineering output. The bottleneck isn't how fast a human can type or write code anymore. It shifts. Now it's about the time it takes to review and validate that AI-generated code.
Precisely. It's all about maximizing overall throughput and efficiency. The metrics are evolving to reflect this new reality, where AI is a core part of the engineering team.
This has been a genuinely eye-opening discussion. If I had to pull out the most important takeaways from this report, what would they be?
First, the build versus buy decision is real. Elite engineering organizations are choosing to build their own AI coding agents because they need that deep, custom integration with their unique tools and code bases. Generic solutions just aren't cutting it at their scale.
Right, and it's not a free-for-all. There's a convergent architectural pattern emerging. Think Slack invocation, isolated sandboxes for execution, and a tight feedback loop with CI/CD.
Exactly. And the third key takeaway is how open-source frameworks like Shopify's Roast and LangChain's OpenSui are democratizing this. They're making these powerful patterns accessible to a much wider range of companies, so it's not just for the giants anymore.
And then there's that fascinating philosophical divide. You've got the pragmatists, like Stripe, using AI to scale code generation, but keeping humans firmly in the loop for review. And then the radicals, like StrongDM, who are completely eliminating human review in favor of massive-scale behavioral validation.
That divide is probably the most thought-provoking part. And finally, the new metrics. We're moving beyond lines of code to things like the percentage of PRs merged from background agents, which Ramp shows can be as high as 30%. It's a whole new way to measure engineering output.
It really is. So for our listeners, I want to leave them with a couple of questions to ponder. First, how will your organization adapt to these new metrics of productivity? Are you ready to measure your team's output by how many AI-authored PRs get merged?
And second, given the philosophical split, which side of the human in the loop versus no human review debate do you think is ultimately more sustainable and robust for long-term software development, especially for critical systems? It's a trade-off that every engineering leader will need to confront.
Ship it carefully.